I don't know if you can see that or not, but this contact it's welded. So I think I have it. To fit it though, I have to loosen the bolts that hold the pump down. This is soft copper. Hard copper would be, I think, impossible to bend like this without doing what I did before, which was kink everything. Okay, I think that's all good. Put the belts on. There's a calculation on the web. You give it this diameter, outside diameter, you give it that outside diameter, you give it the pulley, the belt size, which is a B, and it tells you the center. It also tells you what kind of gap you've got here. It also calculates the length of the belt. Now I ordered these as a 57. They were supposed to be a 56 3/4 or something. These are 57s, but if you look here, the belts stand quite a bit proud of the pulley. I don't know if that's because there's a thick coating on the pulley, but paint, but I think these don't have a thick coating of paint, and they also stand quite proud. So I guess that'll wear in, and the motor will have to be adjusted out. Okay, so the problem with this bracket, the way I've made it, is either one of these will pull the motor, and it kind of swings out, which means one of these belts get tight and the other one doesn't. What I've changed this to is this is a pusher bolt now. So when I'm tightening this one, it'll push against this one and try to get it to swing back straight. This valve here, this is the shut-off valve. It has the power going into it. This is set to a pressure. It cuts off the motor. It also has a vent here. This will vent the air compressor so that it doesn't start against pressure. Anyways, this is the part that went bad. The previous owner already had this switch, but he just opted to buy another air compressor. So I got the switch. I have to change all this stuff out now. This is the new one. It's got the same little vent. The back side is where I've got to screw in the relief valve. There's a pressure gauge here, which I'll put here. And then there's a plug on the back, which I'll just change that out, and there's a plug there. So, and there's the on-off switch. I can turn it on or off, or enable and disable the switch so that it turns the pump on, or you can just make sure it doesn't ever come on. There you go. Comes on at 100 psi, shuts off at 135. Okay. Now it doesn't matter which of these goes on which because it's alternating current. So either one will work. Okay, this doesn't have to be mashed flat, it's just got to keep it from coming out. I've tried to find a bit of rubber that can stick in there. It's a special little thing that's like it's just like more rubbery stick in there, but it's a cone shape. That when you screw this on, it compresses it in there. What I've got instead is this Scotch. It's a 3M product, Scotch 23. And what it does is it's kind of a live rubber. Not really uncured, I'm not sure, but it bonds to itself. You don't need much of it, and it'll stick to this rubber here. I'll just push it in a little bit to be the strain relief. I'll just build this up a little bit. It's sort of the same as using a vinyl tape. But vinyl tape, the glue will get soft, and it will shift and move and bend, and it just doesn't work very well. This stuff here it bonds. It'll bond to the rubber, it'll bond to itself, and it'll make a good seal as well if you're worried about that. And yeah, that'll make my strain relief. I've got some Teflon tape wrapped around there, so it'll be a bit of a lubricant for this nut to turn. Easier anyway. I'm disappointed in Eaton. It's an Eaton air compressor. I finally managed to touch base, and I'm not going to fault their people. I think maybe as a business they've made some bad decisions. I've still got the box sitting over there that it came in. Not that it was, it wasn't doing anything. The box was just kind of, it was hanging on by a couple of staples. It wasn't doing anything. There was no packing inside. The pallet that's over there, it was bolted quite securely to that pallet, and that's good. But there is no, I've mentioned this before, there was no manual on this. I don't even know how they knew to deliver it here because there's no shipping documents at all. On the paper, on the compressor itself was a paper tag wired on. The only words on it were 5 horsepower. That's not very good. The receipt that I got after purchase from Eaton is that had a serial number and it had a part number. Now, that could have been for a bag of hamsters or who knows what, because there's nothing on this to confirm that this has a serial number, or there's no stamps. There's no marks on the bottom, on the sides, anywhere on the top. There's just nothing. There's nothing other than the word Eaton. That's the only word on this entire compressor. I contacted Eaton, and they had some kind of problem with their computer. I had a couple of emails, and the person that I contacted said, well, our computer's down, try again later. I still couldn't get a manual, and that was all I was trying to do, was get a digital manual. Their website was having problems, and I did find a couple of manuals, not for this one, it was for other machinery, and that was just to tell me something. What's the maximum RPM? What kind of rate? What's it? I don't know anything about it. Okay, so today finally I was able to get on, actually talk to a human. They called me. I'd left various voicemails and stuff on their system. And I had 3 calls today. It's amazing. I talked to a fellow who was very helpful. He sent me a book on this machine. And I need to backtrack a little bit because yesterday I had managed to find some information, not from Eaton, but from eBay of all places, where somebody was selling this Eaton, a pump like this. And it was a part number that was on the paperwork. That part number translates to a 7.5 horsepower air compressor. Well, that's disappointing. This is supposed to be a 5. I don't know. Anyway, so today they called. I talked to them at length. I had connected a piece of copper tubing up here, which is not going to do anything. For continuous run, which is a feature you can do with this pump, it's set up to do it, you put a tank pressure at these fittings. And what it does is it lifts the valves. It's basically allowing the pump to turn. It doesn't vent any pressure from the tank. The tank is at a pressure and it stays there until basically the pressure drops to a point where the pressure is released from these valves and the compressor starts compressing again. There's a benefit for that, and it keeps it from cycling. The motor doesn't cycle on and off. The pump has cold air being drawn into it, keeps the pump cool. There's less stress on the system. You'd use that for a sandblaster or lots of big heavy air tools. Might be something I investigate later. But for my purposes, I don't need it. And they say if you don't want to use that feature, you just leave this pipe open on the end, and the valve, it'll just operate as a normal compressor. The other thing I had to find out, and it was the important thing, is this a 7.5 horsepower? Is it a 5 horsepower? It makes a big difference to the motor because this is only a 5 horsepower motor. The other thing that, because it's a Ingersoll Rand, it's a 3450 synchronous AC motor. It's designed to use an 1800 or 1750 synchronous RPM motor. Has better starting torque and all that. 4-pole motor, this is a 2-pole motor. Well, I don't have that. I don't want to buy another motor for that. I had to get a smaller pulley to make this work. It's a 3-inch. And I thought I was doing the right thing based on what little information I could get. And this is, a week ago, 2 weeks ago. Well, today when I'm talking to them, they're going, well, no, here's your manual, which is confusing. I'm going to get off on the manual now. The manual had page 2, which said the part number that came on the paperwork says this is a 7.5 horsepower motor. But page 5 in the same manual, says it's a 5 horsepower motor. Well, that's just confusing. Whatever. The guy pointed me to page 5. He said, don't pay attention to page 2. It's a 5 horsepower motor. And you need a 2 3/4 inch pulley because there's a RPM. And the faster you spin it, the more horsepower it takes. Well, based on the information I had, this is a $35 pulley there, and it's a 3-inch pulley. Doesn't seem like much, but it's a difference between 770 RPM and 700 and low 700s RPM. And that makes a big difference to the motor on load. So, am I overloading this motor? The breaker's not going to trip because that's a 50 amp circuit I've got going into this. I had to find out what amperage draw is coming into this motor. Well, in another life, I used to play with clamp-on AC transformers, or amp meter in this case. They make tools that just do this one purpose. But if you only have a multimeter like this Fluke, and this is a very simple one, there's no range scale at all, it's all self-adjusting. I haven't used this for 35 years, so I've forgotten how to use it. And no manual, they don't make it anymore, it's obsolete. Fluke has one, used to make one similar, and it's very similar, but pretty much all the ones I could find online now are 1,000 to 1. Now what that basically means is just what I've got written there. 150 millivolts is equal to 150 amps. Yeah, so 19 point something amps. Great. But still, Eaton, come on people, you can do better than this. Wow. Anyways, I've got it working now. I know I'm not going to blow this up. I'm not going to blow that up. I'm not going to blow this up. This leaks. It's a pressure relief valve. Not supposed to do this, but I'm going to do it anyway. But the seats in here have gone bad, and I'll probably have to replace this piece, because if I press my hand on it, it doesn't leak. But if I release it, you can hear it hissing. There's another one there. So I'll probably replace this just to make sure. Right now it's leaking air, and it'll bleed down and run unnecessarily. So anyways, I've got a working pump now. Well, the fun never stops. I was test running this, and It worked a couple of times, the switch that is, and then I noticed that it didn't shut off. I was watching the pressure gauge. Pressure gauge went up to 130 before and then shut off. Well, it went up to 130, 135, 140, and I figured there's a problem. I knew that there was a problem with this before. He had a new switch. He handed me this new switch, which is a, it's an Ingersoll Rand. Now, the Ingersoll Rand new switch rated for 240 volts, 26 amps, full load amps, FLA. Right next to it is another one, LRA, which I don't know what that means, but it's probably something to do with inrush current to start the motor. Short period, short duration. 130, I think it's 130 amps. Now that's the new switch that came with this. Here's the guts of the original switch. It's a Hubble Industrial Air Power. I'm reading the label on this one. It's the same, 240 volts, 26 full load amps, and 130 starting current amps, I guess. Well, I did some troubleshooting. It wasn't hard. I don't know if you can see that or not, but this contact it's welded. Now, this was like this. It wasn't, I can run the switch, it wasn't turning off. That's why I had to unplug it. And I had to take a screwdriver and pry this one off. That meant this one's welding as well. This contact is doing exactly the same thing, or this little switch. Brand new. It's happening exactly the way that this one did, and this one melted. Okay, Ingersoll Rand switch. Ingersoll Rand equipment. That's now an Eaton pump. This is all shipped as it was from the factory. That's why it didn't shut off. This switch here, or the other one, welded the contact, and this one gives up actually a little bit. This worked a couple of times, and I noticed that this pressure relief wasn't relieving. When it shut off, there was no hissing coming on here, and that's venting the high pressure from the header pipe there. So that meant this one was welded. This one actually has a bit of flex. You can see it moving, or I can anyways. Let me show you. This is properly operating now. I can turn it on. Had there been power, this would come on. And then, I don't know, it's supposed to go up to 130 PSI here, and it would shut off. Well, it went up to 140. I run the switch, it wouldn't work. You see what's happening here. This little, it's plastic, this little bail. And that was actually coming undone enough to actually, before, the motor would shut off, but the pressure relief wasn't working. And that's because that's not going to work unless the whole thing comes free. So had I just connected this up and let it run, it would be the same failure again. It is run and run and run. It would exceed everything. Okay, well, I'm not going to trust this switch anymore. I bought another one, but I'm not going to run it like this one is connected. This is a mechanical pressure switch. It senses pressure coming straight out of the tank and mechanically trips something in there, and it trips this out of contact so that the motor stops. Well, I know the motor is right at its limits of this thing, what it's rated for. The same would happen to this, just like it did to the original switch. I'm going to put on a magnetic motor starter. And this one's rated, it can be adjusted here with this little knob, between 32 and 48 amps. Now, it should be good enough for a 7.5 horsepower motor. This new switch, all I'm going to do is I'm going to hook this up so that it just runs the magnet in this, and it'll still have an on-off switch using this here, the on-off switch. So this will still have the mechanical shut-off inside. It gets to a certain limit, the contacts in this fall out, and all it does is de-energize this, and then this will turn off the motor. Diagram number 1 shows an on-off switch here, which is a momentary start, and then it's got another button that you press off, and it de-energizes the contactor. But in this case, I'm just replacing this with the switch over there. If you look at this mounting plate, you'll see this is a square corner. All the other corners, like this one, are angled off at 45 degrees, that corner to that corner. This was meant to have something mounted to it. It's even got holes. I'm thinking because this tank was probably also used on a 7.5 horsepower motor, or even a heavier duty 5 horsepower motor, a magnetic starter would have already been mounted here. So it's probably what they should have done from the factory. Problem is this motor sticks out far enough where I've got to space this out a little bit. I've put the new switch on here, but instead of facing it up, I'm facing it to the left. I made it easier for this connection here. And pressure gauge is still where it used to be. The pressure relief is now poking straight up. There's the plug. Allows me easy access to the switch. And also a good connection from the bottom here to go to this. Now I've made this bracket. There's this bolt on here. I'll put that on now. I've made a pigtail. That'll go between the starter and the motor. Run the wires around back here somehow. And as well as that, I have redone the power cord because it had some iffy decisions made on it before. I just wanted to get fresh ends done. One thing about the connectors here, the top of this is made to accept just bare wire. You can just poke it in there. But the bottom, I'm going to make up rings, little crimp-on rings, because the bottom here doesn't have a plate that holds it tight. It's just got a screw. So I'll fix that up. I've also got to put these earth connectors. I'll put those both down here because there's a thing made for that. Yeah, here we go. I'm not going to make any new holes for this wire. I found this in my scrap bin, which is one of those straight reliefs that you drill a hole and you kind of squeeze this around the wire and it just stays in. I'm going to do a test. Here's the power. Here's the plug to the top of the magnetic contactor. This switch is off, but there's a test thing there I can use. And this should just kick in. And I should release the button, it'll kick out. Yes. Cool. Right, so the span is actually 40. It dropped down to just under 90 psi. So the span is 90 to 125. What is that, 35 psi? So I don't want it to be that big of a span. The instructions here, somewhere, say that there's 2 screws to adjust. The one to the right, you turn it clockwise to increase cutout pressure without affecting cut in. So what I want to do is go counterclockwise. Success. It cuts out now at around 125, 130. It cuts in at 100. All is well. That's great. This has been a real adventure. I have way blown the budget. This was $85 by itself. All the copper I've had to buy, all the tools I've had to buy. Probably can't count that, but well, I can count the copper because that's materials. The tools, I can use tools somewhere else. $900 for the pump, roughly $500 for this tank is what it's worth. I think I gave $300 for it. So that's $1,200. This was $80. This switch here was another 20. Pulley was actually $45. The belts, another $30, $40. And yeah, next time I'll just buy another compressor because I'm trying to build my own, at least using the stuff I've used. I think if you go online, you can find really cheap pumps for $200, less than $200. You know, I had to pay shipping. The pump was $500, $550, roughly, and shipping was another $330, and it just went crazy there. So that's the main cost for this. I'm hoping to get some of my money back on the other pump because I don't think it's really bad. I can do some, I'll take it apart and just make sure it's in functioning order. And I'll get a couple of $100 there selling it as an aftermarket to someone else. So, yeah. Now, this isn't all the money I'm going to have to spend on this because just a compressor, if I want to mount it outside, that means pouring a concrete pad, probably a little shelter over it. I've got to run wiring to it. There's also a power box that I'll have to, you know, on the wall so I can plug into it. Another couple of $100. And on top of that, another $200 for the pipe work. 3/4 inch plastic line, air line. And it comes with the key as a kit. There's valves and T-joints, stations. So yeah, putting in an air compressor is a pretty expensive thing. But again, this is shop. It's going to be permanently mounted. So you get what you pay for, I guess. So thank you for watching. Please subscribe, and happy air compressing.